Again, we have exponential equation. We have 3 to the x, and we have 243. So I'm looking at this 243. Can I write this as power of 3? I don't know yet, so let's start. 3 times 3 is 9, times 3 is 27, times 3 is 81, and then 81, let's multiply that by 3. Well, 1 times 3 is 3, 3 times 8, 24, so 243. Alright, so we have 1, 2, 3, 4, 5 threes. So 243 is same like 3 to the 5th power. And on the left side we have 3 to the x. So all we need to do now is look at our exponents and compare them. And we see that x equals 5. Done deal. Next problem, same procedure. We'll look at a 5 and we'll look at 625. Can I write 625 as power of 5? Let's see, 5 times 5, that's 25. Another 5 times 5, that's also 25. And I happen to remember that 25 times 25 should actually equal 625. So it's 1, 2, 3, 4. So 625 is same like 5 to the 4th power. So again, we'll look at our bases. They're same, so we ignore them. And all we need to do is to compare exponents. So x equals 4. Next one. 3 to the power of x equals 729. So let's try again. Can we rewrite 729 as power of 3? Let's start. 3 times 3 is 9, times 3 is 27, times 3 is 81. So this here is 81 so far. Times another 3, that will be 243. And then, let's see, 243 times another 3. So that would be 9. 4 times 3 is 12. 2. Right, 1. 2 times 3 is 6 plus 1 is 7. Yes, so that's 1, 2, 3, 4, 5, 6 threes. So it's 3 raised to the 6th power, and that equals 3 to the x. So the only thing we need to do is look up, compare our exponents. Since we have the same base, we ignore the 3. So x equals 6. So in this example, again, we have 7 to the power of x. My question is, can I write this fraction so that I can number 7 in that fraction somehow? Well, 49 is 7 to the 2nd power, so I can rewrite this as 1 over 7 to the 2nd power. And from your rules of exponents, if we have 1 over something, that's same like 7 to the negative 2nd power. So I rewrite my equation as 7 to the power of x equals 7 to the negative 2. Now I can ignore my base because it's same. And the only thing that's left is compare exponents. So our x equals negative 2. Next problem, 8 to the x equals 4. So we look at our bases and we see, can we write this, these two numbers so they have the same base? Well, 8 is same like 2 to the 3rd power, and then to the power of x. So 2 to the 3rd times x. 4 is same like 2 to the 2nd power. So now our bases are same, so we can ignore them. And now we can set exponents equal to each other. So 3x equals 2. Divide by 3 and we get x equals 2/3. Next problem. So we have 1/2 to the x and we have 32. So let's see if we can express these numbers with the same base. Well, if I think about 1/2, that's same like 2 to the power of -1. And then that whole quantity to the power of x. If I look at 32, well, let's see, that's 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So 1, 2, 3, 4 power of 5. Now we use rules of exponents and we rewrite the left side. So we have 2 to the power of -x equals 2 to the power of 5. Well, now we can ignore base because it's same. So we're left with -x equals 5. Divide or multiply by -1 and your answer is x equals +5. Similar problem here. Now we have 1/4 and we have 64. Well, I remember that 64 is same like 4 times 4, which is 16, times another 4, which is 64. So I can rewrite this as 4 to the power of 3. So the right side is 4 to the power of 3. Now 1/4, by the rules of exponents, that's same like writing 4 to the -1. And then we have 4 to the -1 all to the x. So if we use properties of exponents, we need to multiply these two. So 1/4 to the power of x actually becomes 4 to the power of -x. And now our base is same, so we can ignore it. And all that's left to do is set exponents equal to each other. So now we come to -x equals 3. Divide by -1, x equals -3. The next one. So we look at 3/4 and we look at 27 over 64. And let's see if we can rewrite that somehow. Well, 27 is same like 3 times 3, which is 9 times 3. So that would be 3 to the 3rd power. 64 is same like 4 times 4 times 4, which is 4 to the 3rd power. So really, what we can do is we can rewrite the fraction as 3 over 4 all to the 3rd power. And then on the left side we have 3 over 4 to the x. Our base is same, so 3/4 is gone, and all that we need to do is look at our exponent, and we see that x must equal 3. So in this next problem, we do the same thing like one before. So 4 over 9. We'll look at 4. 4 is same like 2 squared. We'll look at 9. 9 is same like 3 squared. So we have 2 squared over 3 squared. We can simplify that and write it as 2 over 3, everything squared. And that's exactly what we'll do. So to the right we have 2/3 to the 2nd power. To the left we have 2/3 to the x. Well, our base is same, so we ignore that. And then we compare exponents, and we see that x equals 2.